Yeah, good evening, everyone. So another 5 minutes. We'll wait for the 5 minutes. Still interns are joining the meeting. Another 5 minutes. We'll start the session. Okay. So yeah, good evening, everyone. So welcome to the fourth day of internships session. Okay. So today we are going to discuss about different types of Python library. Yeah, am I audible, guys? Please reply in the what chat box. Am I audible? Please reply in the chat box. Okay, thank you. So here we are going to understand some important concepts using libraries. Okay, before going to the libraries, let me give a clear picture. What is the need of the libraries? Okay, and how important Python programming is when compared to the other programming languages. Okay, so let me share my screen. Concentrate, guys. Okay, I think my screen is visible to all. If my screen is visible, please put a message in chat box. Okay, so I hope my screen is visible to all. So let us start our session, today's session. Okay, let me open the Jupyter notebook, guys. So go to the desktop and go to the apps. I'll search for Jupyter. Okay, and click on Jupyter notebook option. Okay, so here Jupyter notebook will open. So till then, what we'll do? Okay, so the command prompt has been opened. Let it initiate the kernel and open the Jupyter notebook. It takes some time, guys. Okay, so I think kernel has been started. So Jupyter notebook is open now. So let us understand some important concepts in uh, Python. Okay, so I'll go for a new page, new file for today's session. Let me create a Python 3 file. Okay, so here I'll just rename it. I'll make this as day 3, day 4. Okay, so SDP 110. Then I'll put today's date for my reference. Right. So this is the file name what I have given. Okay. So here we understood complete basic concepts of Python, Python basics. So now we'll move on to the important libraries in Python. Okay. So if you want to discuss a libraries, what is the need of using libraries, guys? Okay. So before going to that, so let us have a brief overview about Python. Okay. All right. So look at the screen, guys. So here, uh, just think about today's technologies. Just think about today's softwares. Just think about our daily routine, like daily usage of different types of apps, different types of softwares, and so on. We are really dependent on coding, guys. Okay, because coding is a such a language, okay, or it's such a tool which is going to automate many of the things in our real-time lives. Okay, like for example, if you just think 15 years back, you can ask your parents or you can ask your elders. Okay, so they will tell that if I want to transact a money from one account to another account, I should stand in a queue in the banks. Okay, or else I have to do money order and so on. It's very hectic. Okay, 15 years back, 20 years back, you can take 20 years back. Okay, so later what happened, coding gets boom. Okay, many softwares are developed. Okay, people used to do people uses internet banking. Okay, then comes the different Android systems where different apps came into picture. Nowadays we are using phone pay, Google Pay. There are so many other like UPI related applications. Okay, so we can send the money in a single tap. So not only this, there are so many, like every second of our life we are dependent on coding, guys. Okay, all these systems, behind that there is a coding. Okay, let me ask one question. If I say someone, which is the best programming language to build web applications, web apps, websites, so majority of the people will say it's a JavaScript. If I ask someone which is the best programming language, to build iOS applications, okay, many of the people say it is Swift. If I say Android application, many of you say it's Java. Okay, if I say like there are so many applications, C++, C# is used for gaming, software building. Okay, PC application. Okay, so my question is there any language which can support all these things? You can use a language for web development, you can use a language for building some apps, we can use a language for like developing games. Okay, so that programming language is Python, guys. Okay, Python can be used in for different types of application. Why? Is there any like speciality in this? Python is generic programming language. Okay, so you can use it for anything, but there is some condition. Like for example, if I say I want to develop the PC applications or front ends, or you can say that a GUI, UI, user interface, or graphical user interface, you can use Python. If you want to build an application for machine learning, artificial intelligence, deep learning, data science. Okay, so Python is best suited language. Okay, if you want to build web applications, web apps, websites, okay, even Python can be used because it is having so many libraries, guys. So behind all these advantages, there are so many libraries involved. Okay, if you are willing to build a machine learning application and deploy it into a real time, you have to go for some libraries which are helpful to build that application. Okay, our job till now, what we have done, we understood basic level of Python, the foundation. Okay, understanding the Python language, how to write a code, what are the different operators, what are the different control statements, what is function, what are modules, we understood. Here we are discussing some more modules, different types of modules which are helpful for building required application. Okay, so this is a Python, guys. So we are going to understand this, some general basic Python packages what we are going to learn. I will display here, please concentrate, guys. So first application, first library what we are going to learn in these sessions, in these internship sessions, is NumPy library. Okay, we'll discuss what is this NumPy. Second library, pandas. Okay, we'll also discuss this library. Third, matplotlib, it's for plotting. Seaborn is also visualization library which is built upon the matplotlib library. Okay, and also the one more thing, scikit-learn. There are some more libraries we are going to use. OpenCV will use. Okay, we'll use profiling, There are so many frameworks, so many libraries we are going to use in this 4 weeks of session. Okay, so first we'll understand these basic libraries, so it will be helpful for us to solve any project. Okay, so let us understand one by one libraries, right? So here uh, in the previous session, I hope everyone understood what is a module. Okay, what is a module, or what is a package, what is a library? Okay, module is very simple, guys. So module is very simple. Okay, so what is that module? For example, if you have an application, assume that this is your main application. Okay, if you have an application, I call this as main application, your application, main application. Okay, so if you have an application code, okay, so this application code requires some libraries are nothing but some external program already written by someone else. We are just calling that library, okay, in our program, so that I can utilize the functions or methods defined in this library. That's it. Okay, so these are external files. Okay, we just call that and we utilize the functions present in that library. For example, if I want to build machine learning application, ML, I will use some libraries. Okay, what are the libraries? I'll go for NumPy, I'll go for Pandas, I'll go for Seaborn, and so on. Okay, so like this, we are going to use these libraries based on required application. Suppose if you want to build web development, okay, you are going to use one more library, okay, that is called Flask, that is called Seaborn, that is one is called Django. There are so many frameworks, Streamlit, Gradio, different types of libraries are available, guys. Okay, so let us use these libraries, these modules in our application. Okay, yesterday we understood there are two types of modules. Okay, one is called built-in modules. Okay, so second one is called external module. Okay, external modules. Built-in modules is nothing but by default it is present in Python interpreter. Python interpreter. I'll just tabulate some libraries. One is called time, one is called math. These are basic built-in libraries, and another one is called random. Okay, so what are external libraries? External libraries is something like NumPy. This is separately a community built this library. Okay, NumPy. One is Pandas. Okay, and another one is called Seaborn. There are so many thousands of libraries, thousand different. Even you can write your own library, guys, and leave it to the Python forum. Okay, so like this, these are the libraries which we are going to use. Okay, what built-in library, it is already present in Python. External library we have to download, or else if it is having, then it is okay. In Anaconda we have some libraries. If you don't have any library, you can install the library. Okay, for example, I want to use a library called NumPy. Or suppose if this NumPy library is not there, you have to install it. Okay, how to install the NumPy library in Anaconda, Jupyter notebook I am showing. Okay, I'll just search for the NumPy install Python in Python. Hey guys, I want to install NumPy library in Python. Right, so I search this, I got some search results. Okay, so there is one website called PyPy, PYPI, Python package installer. PyPy. Okay, Python package installer. Whatever the packages of Python we have, you can install from this website. Okay, this is best website what I suggest. Okay, so I'll just copy. If you want, I'll share it in a chat box. So here are some questions. Sidram is asking, sir, according to you, which language should we learn and why? This is very hard question. See, it purely depends on you what application you are doing, what project you are handling. Okay, it purely depends on you. Okay, see, Python is a high-level programming language. For suppose if you are working on embedded system or any hardware-related application, okay, C++ is very important. You cannot use Python because Python is byte codes. It's a high level programming language. Okay, you can use C++ for low level microcontrollers and all. Okay, so if you want to use higher applications, okay, websites, okay, machine learning, deep learning, you can go for Python because it is having huge support. Okay, Python is having huge support because Python is open source programming language. Okay, it's a open source. And in Python, how many libraries are enough to learn? Once again, I am telling which application you are doing, which project you are working on. Depends on that, you should select the library. Okay, understanding the library is very easy. Learning the library, no need to learn. You just utilize the functions present in the library. That's it. Go through the user document of that library and understand the library. Okay, I'll tell you. Why so many startup private limited companies using Python only? Because Python is open source, crystal clear. Okay, so Python is open source. You can use the Python, and Python is very powerful programming language. See, if I want to do image processing, I have only one single function to do the image recognition. If you the same thing, if you want to do using C, you have to write lines together. Okay, that is one thing. Okay, so Python is open source. You can use anywhere. Okay, there is no end for that. Right. Okay, not an issue. We'll discuss about this one by one. So if you go to this PyPy website, click on this. I'm just showing for your understanding. Okay, so if you want to download any package, Python package, you have to use the command called pip. You have to use a command called pip. Pip is a Python like package installer in Python. Okay, pip, package installer. Right. So you can use a command called pip, then next install what library you want to install. For example, if I want to install, okay, I'll just show you. I'll just copy this, go to the Jupyter notebook. I'll just paste it this. Okay, see guys, here you have to use exclamatory mark in Jupyter notebook. If you are using PyCharm or normal PyCharm, a normal Python, you don't use this exclamatory mark. Okay, I will use exclamatory mark because it is used in the Jupyter notebook. I'll run this code. What happens? It will try to install the NumPy library. Please make sure that you have internet connection. Internet connection should be there if you want to install any library, because it will download from the internet, from Python like installer, from the cloud. Okay, I got some a warning here, like output here, requirement already satisfied, which means that NumPy library is already present. Okay, NumPy library is already present, no need of installing. Listen guys, those who installed Anaconda software, NumPy is comes with Anaconda. Okay, huge packages will already there in Anaconda. If it is not there, you have to install manually like this. Once you install, it is permanent. No need of installing again and again, once in a lifetime, until and unless that software is present in your computer. If you reset the software, again you have to install. That's it. Okay, so that's it. Now NumPy has been installed in my application, Jupyter notebook. Okay, so how to import any library?
or any module. Import that module name, NumPy. For suppose guys, if you want to install pandas, you just replace this NumPy with pandas. Replace this NumPy with pandas. Okay. So like this we can do any library. Please go to the documentation of that from the PyPy what you want to install, and you can install that library. Right. So here first what we'll do, we'll start learning NumPy. Okay, I will import NumPy and I will rename this as NP. Most of the engineers, they use this notation. That's why I'm also following. If you go to the internet, if they say NP dot means, you should understand that it's a NumPy. That's why I'm using the same notations for you guys as well. This is a standard thing what people use. Now you run this code, shift and enter. Okay, now NumPy library has been successfully imported. Okay, can you see this number guys? 2 in the instruction box. What is this 2? This is nothing but execution. How many times execution happened in this kernel? If I run the same line again, it becomes 3. If I run the same line again, it becomes 4. This 4 times you have executed the code. 4 times you have executed the code. One more time I'll do now. I'll do one more time. Concentrate guys. Let's run this. Now the number becomes 5. Okay, so I mean to say that it is a number of execution, not like a number of instructions. It's a number of execution. All right. So I hope everyone is clear with this. So now we'll move on to the actual Python libraries. Okay. So I'll go for this. Okay, the first library what we are going to learn here is NumPy. I hope everyone is clear with this. How to import NumPy? We already done it. So what is NumPy, guys? So here a question. NumPy stands for numerical Python. Okay, all the numerical calculations, mathematical calculations. It may be the trigonometric calculations, or it may be the complex matrix calculation. Okay, all this calculation will done using the NumPy arrays. Okay, so the library is NumPy, which means numerical Python. Okay, now here the NumPy library is used for general purpose array processing. Okay, general purpose array processing. We'll understand what is array and all. Right. So here, how to import NumPy? We already done. Import NumPy as NP. Okay. So here NumPy is a library name. NP is the renaming for NumPy. Okay. So here we already installed successfully the NumPy. So here I would like to tell you guys one small point. Okay, if I use something like this, what is the type? What is the type? Samarth is asking how to install it in VS Code. Okay, Samarth, you do one thing. In the VS Code, you will find terminal. Go into the terminal, go to the terminal and just use a command pip space install space any library name NumPy. If you run that command, it will install the library. In the terminal, you can try. Or else I will show once. Later in this, at the end of the session, I'll show you how to do that. You try from your end. if it is not done, so I'll explain you at the end of the session, by end of the session. Okay, so tell me guys, what is the what is the type of data type of this variable a? Integer, of course. Okay, so this is clear. And what is the dimension? What is the dimension? Please concentrate. Dimension. 0 dimension. Very nice. Sumer is saying 0 dimension. Okay, its dimension is 0. There is no dimension. And we also call this as scalar value. Okay, scalar value. Scalar value means it's having single data. Okay, single value. There is no direction, only magnitude. Okay, when we say array like data, here also we say array like data, not array actual array, array like data, array like data. These terms are important, that's why I'm saying. What is array like data in Python? Anyone? What is array like data in Python? Please, if you know, reply it. Array like data. Array is nothing but collection of data, sequence of data, series of data. Okay, in Python, I will define some data like this. 1, 2, 3, 4. Tell me guys, what is the dimension here? What is the dimension of this data? What is the dimension of this data? Samarth is saying 1D, very nice. Okay, this is one dimension. Okay, right, left to right, right to left, whatever it may be. It's a one-dimensional data. It's a collection of the data, one dimension data. Okay, so this is not scalar. It's not scalar because it is having a dimension, right? So if I want to write two-dimensional array, 2D list, 2D list. See guys, array like data may be a list or maybe a tuple. Okay, these two things are array like data. Okay, what is two-dimensional list? Okay, I will say a two-dimensional list. If I have a bracket in the list, single opening and closing bracket, it's a one-dimension data. When I have two-dimensional data means matrix. Okay, I'll just show you. Assume that I have a matrix like this. Okay, some 3 by 2 matrix. 1, 2. Okay, 2 by 2 matrix. 3, 4. This matrix, I want to write it in a list format. How can we write it? Okay, tell me guys, how many rows and columns we have in this application, in this list? How many rows and columns? Number of rows, number of columns. 2 rows and 2 columns. Okay, so if you want to write this using list, you have to use outer bracket. Okay, and you have 2 rows, so inner bracket. How we write in list format, this one, and each row is separated by comma and one more row. Okay, so here 1 comma 2, this is list guys. Look at the screen, this is very, very important. 3 comma 4. Okay, so 2 list. If you have 2 rows, 2 list. If you have 10 rows, 10 list. If you have 20 rows, 20 list. Are you getting? And each list is by separated by comma. And what is the dimension? Columns. Column is nothing but inside each list, how many elements? That is columns. Okay, the same thing here. If I say 2 by 2 matrix, first one outer bracket, and how many rows you want? Inner bracket. I have taken here 3 rows. 3 rows. Are you getting? Inner bracket. How many columns? 2 columns. 1 comma 2, 3, 4, 5, 6. Are you getting, guys? This is two-dimensional matrix. Two-dimensional list. Okay. So if I print this C, I got two-dimensional list, right? So this is two dimension, guys. This is two dimension. Even you can use curly, like round brackets, it becomes a tuple, right? Like this. This is different types of data. What I would like to explain you. This is very, very important. Concentrate, guys. Now we have one problem with the list. Why we go for the numpy? You may ask, sir, we have a list, right? Why we go for the numpy? Okay, here is a problem. Like, one thing is, list can be consist of different types of data. Okay, I will say one list A1 and B1. Just observe, I'll take two lists, 1, 2, 3, 4. I print A1 plus B1. Tell me, guys, what will be the output if I print A1 plus B1? What will be the output? Both should add it, right? Yeah, let's run this code. What happened? I should not do this, right? 1 plus 3 should be 4. 2 plus 4 should be 6. But this not happen because list or doesn't have a type, similar type. It's a different type. That's why we cannot use list in mathematical numerical operations. If I want to add, it will not add. It gets concatenated, right? So that is the case. We'll go for the numpy arrays. Okay, numpy arrays. Okay, what are numpy arrays? We'll have a discussion now. Okay, so here before going to the numpy array, understand the types of arrays, guys, based on the dimension. Based on the dimension, what are the types of arrays? First one, single dimension array, one dimension. Okay, here some terms are very, very important. Please concentrate. Here, one dimensional array. If I say one dimensional array, here I have 4 elements, 7, 2, 9, 10. And you can see axis 0, single axis 0. There is no rows concept. Only number of element. There is no rows and columns, single row. We should not call this as a row for one dimension. We can say series of element, collection of element. Okay, so number of elements. And axis, how many axes we have? Single axis, because single dimension. If I say two dimension, there should be two axes, x and y. Three dimension, three axes, x, y, z. I think you have seen 3D, maybe 3D movies like Avatar or something. Okay, it feels like it is coming near to us, something like that, because it's a 3D. It looks like object, right? So, and one important thing you have to understand, shape. Here, since I have 4 elements, I will write in a tuple format, round brackets, 4 comma. Okay, the shape is 4 comma, right? Number of elements, comma, that's it. Nothing, you don't write anything else. Okay, so this is array type, one dimension. Okay, what are the examples? There are so many examples, guys. A straight line which joins the points. Okay, number of points on the straight line. Second one example is student marks. Okay, how many marks scored by the students? A series of marks. Okay, this is one dimension. Come to the two dimension. In the two dimension, we have a concept of rows and columns. Okay, rows and columns, just like table kind of data. Right here, we'll have two axes, axis 1 and axis 0. Axis 0 is nothing but number of rows. Axis 1 is number of columns. Please keep in mind. Why it is like this? Because I think we use the shape, right? Always, if I want to say the shape of a given matrix is, first we'll use number of rows, then we'll use number of columns. Rows into columns, right? Okay, that is the case. Axis 0 has been given the for the rows. Axis 1 will be given for the column. Okay, and you can see the shape. 2 rows is there and 3 columns will be there. Any example for 2D? Best example is pictures. Okay, black and color, like white and black pictures. Okay, black and white pictures. Okay, similarly, 3 dimension. Here, concentrate, guys. This is a bit important. Okay, if you see from the top, see from the top view. From the top, if you see, there is axis 0, means number of channels. Here we have 1, 2, 3, 4, 4 channels. If you look from the top, please watch from the top view, you can see it is having one upon another. Okay, there are 4 channels, and each channel is having single dimensional data. Like first is 4, axis 0, number of channels, axis 2, which is nothing but rows, number of rows. Okay, you can see from the top, 2, 3, 4 is the rows. Okay, 3 are the rows, and how many columns we have? 2 columns. Are you getting, guys? So like this, first one is in 3 dimension. First one will be the channel, second one will be the row, third element will be the column. Okay, best example for this is anything like space, or you may take Rubik cube. Okay, there are so many things. Any solid particle that comes under 3 dimension. Okay, we can have these types of dimension: 1 dimension, 2 dimension, 3 dimension, and I will tell you, NumPy can be used for n dimension. There is no limit. N dimension, guys. Okay. So, but it is impossible in real time to visualize. For visualization, it is very tough. More than 3 dimension, we cannot visualize it. We cannot see it. Okay. So, but processing, data processing, we can do more than 3 dimension using NumPy arrays. That's why it is very, very popular and a basic library for all the different libraries. Okay, pandas will use NumPy as a base library. OpenCV use NumPy as a base library. Wherever there is a need of calculations, mathematical operation, okay, numerical operations, we make use of NumPy library. Okay, so here we have some concept we have to understand. Let us move into that and we'll understand. Okay, first thing we'll see of how to create NumPy arrays. Okay, here I'll clarify your doubt. Why this list is not used? Why we used to? Why we go for the NumPy array? Okay, let me import NumPy array. Import NumPy as NP. Okay, I am importing NumPy array, guys. I have used the name NP. Okay, for NumPy, I renamed it. So I should use NP only throughout my program, because I am saying NumPy as NP. You should not call NumPy, it's an NP. Okay. Now, how to create a array, NumPy array. I'll take one small example, guys. I want to create one NumPy array. How do I create NumPy array? Okay. I'll take 1 dimension array, single row. There is no row concept. 1, 2, and 3. Okay, here I have 3 data, 3 elements in a list. Let us try this. How to create a NumPy array. Concentrate, guys. Concentration is very, very important. Okay, here I have a function called np.array. Okay, np is a NumPy library. Array is a function present in the NumPy library. Okay, let us understand this. What is this NumPy array? You want to understand this? We'll use this NumPy array. np dot array. If you want to know about this function, NumPy array, okay, if you want to check general syntax and so on, you can copy the np dot array and we can search it in a Google. Okay, we'll see this. Right, NumPy array in Python. I'll use this. See, guys, there are so many websites are there, but there is one official website of NumPy. Okay, a community, a company who developed NumPy, we can go to that official website. It's a numpy.org, numpy.org.
Okay, so I'll just go to this link to understand more about the NumPy array. See guys, this is one user guide API reference of a NumPy community, NumPy library. Okay, so here I have a function called numpy.array. Here don't get confusion. Here I am saying np.array. Here it is numpy.array because numpy only we renamed this as np. That's why I'm using np.array. Here this fellow is showing numpy.array because he is using full name of the library. Okay, don't confuse. Right, here what are the important things? Okay, look at this function and tell me guys which parameter is non-default. Which parameter is non-default here? Just reply in the chat box. Here we have to pass so many parameters, right? So many arguments. One is object, one other d type, copy, order, sub okay, ndim, like, and so on. Tell me which is non-default one. I think yesterday we understood functions and how to define default variables. Okay. Default parameters, how to define, we have seen. Now it's your turn. Order, ndim, and type. Nihal. I am asking non-default. It is not a default. Okay, I think yesterday we understood one concept like if I have created a function, something like def function. Okay, I have taken one a comma b. Okay, so both are non-default here. There is no default value. If I say b is equal to 1, now b is a default one. B is a parameter which is having default value. Okay, so a is non-default parameter and b is a default parameter. Right, so that's why it is very important while dealing with like functions from a library. Okay, here we know that object, there is no default value. Okay, we can say object is non-default. D type, there is some value assigned to it, none. Copy, there is some value, true. Order, there is some value, k. Sub okay, ndim, like, nothing. Everything is default one. Okay, only object is non-default. You have to give this. You have to give this data. Okay, so let us try one application here. So NumPy array, I'll take the same example here. 1, 2, 3 I will take. Okay, now come to the understanding of this function. So we know that this is function and there are so many parameters are there. Okay, what are these parameters? We'll have a look. First parameter, object. Object is compulsory, right? You have to give or else it will throw us an error. Okay, object, array like data. I am saying array like data. Array like data in the sense it may be a list or it may be a tuple. Okay, so any array, any object exposing the array interface. Okay, so let us understand this by giving the object. Okay, so here I am using np.array and here I should give array like data, something like I'll define something here, a is equal to some array 1 2 3, and using numpy array I'm also using a here. A is nothing but a list, one-dimensional list. Okay, let's run this code. See guys, I got the output as array. Yeah, all of you please try this. Okay, all of you done this? So this is how array can be created. If you want to save somewhere, n1 is equal to np dot array. Okay, let me print this. Print n1. Let's run this. Okay, you're thinking that it is a list. You're thinking that it's a list. If I run this code, I got the data 1, 2, 3. Make sure that remove from your mind this is not a list. It's an array because we converted the list into array using np dot array. If you want to print the type of this data, type of n1. Let's run this. See guys, this is saying a given variable n1 is of a type numpy array. Numpy dot nd dot array. Numpy n dimensional array. Okay, are you getting? So this is how we can create a numpy array using single dimension list. Using single dimensional list. Okay. So first, suppose if I want to create multi-dimension, just copy this. If I want to create more than one dimension, for example, I'll take two-dimensional example. I have used here opening and closing bracket. In between, I'll add one more list. Okay, say 4, 5, 6. Okay, this is the two-dimensional matrix. Let's run this. Okay, guys, I got the two-dimensional list. 1, 2, 3, 4, 5, 6. Okay, so I hope everyone done this. So this is how we can create an array. So previously we understood this using list we cannot able to do mathematical operation. Is it possible using numpy array? Let us try. First, I am going to import numpy. Then I am going to create two arrays. One is a1, a2. Okay, let me create two arrays. Okay, np dot array is a function, and here I'm going to use something like a list of data. List of data 2, 3, 4, 5. Similarly, you can use np dot array 5, 6, 7, 8. Right. If I run this code, if I add these two, I'm going to print a1 plus a2. Let's run this. I got some value. Only two non-keyword arguments accepted. Okay, sorry. Here it is not sure. This is a list, guys. Sorry, it's my mistake. Okay, now let's run. Can you see, guys, here what happened? Addition operation has been successfully done. Here each and every element will be added. Okay, 2 plus 5, 7. 3 plus 6, 9. 4, 4 plus 7, 11. 5 plus 8, 13, and so on. Try this one, guys. Okay, this is about one-dimensional list, guys. Okay, so here we have seen numpy arrays. Okay, that is at least a1, or I'll copy this from here. Okay, So I have taken an array and I saved it in a variable a1. Right. So now okay, listen guys. Here we have a numpy array. Let me print this a1. Okay, so a1 dot. Suppose I want to understand what is a dimension. What is a dimension? Okay, so I'll say check dimension. Check dimension of given data. Check dimension. Okay, so here there are some functions a dot ndim. This is a function in Python. If you don't use full name, a you can say a dot n. Press tab button. Press tab button. Okay. So if you press tab button, a new window will open, which will explain the. Okay. So here there is a tab button. I think this is not happening. I don't know why. Sorry, this is not A. It's A1. My mistake. A1. Press the tab button. If you press the tab button, it is showing all the required like present functions in that package. Here there are so many functions are there: argmax, argmin, base, okay, clip, compress, conjugate, and so on. Diagonal, data, type, okay, everything will be there. So now we are interested in NDIM, number of dimensions. I can use number of dimension. Let's run this. It is saying one dimensional data because this program is one dimensional. Similarly, if you have a multiple dimension data, okay, so multiple dimension data. This is two dimension data, right? So let me print like so here the variable name is n1 dot okay. So here you can use NDIM. NDIM. So it is showing two dimension. It is the data whatever we have. It is of two dimension, guys. Okay. So please try this one. NDIM. NDIM is used to check the dimension. Okay. A1 dot A1 dot NDIM. Only an attribute. This is not an this is not a method. This is not a function. This is simply an attribute. If you want to check a shape, if you want to check the shape of a given matrix, A1 dot shape. Sorry, this is not parenthesis. Simply it's a shape. A1 dot shape. No parenthesis. There are so many functions are there. These two are very important, guys. NDIM and shape. Okay. So now, for suppose if you want to reshape a given matrix, okay, how can we do that? So we have a function called reshape. I'll just use go for np dot reshape in Python.
We have a official NumPy library np.reshape. You can see here you have three things. In this function numpy.reshape, we have three important things. One is called a new shape order. What is a? A is a nothing but the data, array like data to be reshaped. Okay, and new shape, whatever the shape you want. For example, if you have 3 by 2 matrix, you want to make 2 by 3, you can do it. Are you getting nice? So like this, so we can use a reshape function. I'll just copy the same program what we have done previously. Okay, so I'll just check what is the shape of this. N1 dot shape. See guys, it is showing 2 by 3 matrix. It is showing 2 by 3 matrix. Okay, if I want to reshape this, how can I do this? Okay, please try a program to reshape this given array, N1 array. N1 is an array, right? N1 array, how can I reshape? Please try this one from your end. I'll give for about 5 minutes time. Okay, so I'll do one thing. Here I want to reshape it. How can we do reshape? Okay, concentrate guys. Here, what is a function? Here I have a function numpy.reshape. Okay, so let me go for this. What is the function? NP. Numpy means NP. NP dot reshape. Okay, come to the arguments. Why I'm showing your function, then I am explaining you, because this is a good habit. Okay, so I got np dot reshape. What are the arguments I need to pass? A is nothing but array like data. Second one, new shape. The new shape should be integer or tuples of integer. I should give tuple. Okay, let us understand this. First parameter, I want to reshape n1. Okay, I will take here n1, because actually array we have array that is defined as n1. I'll take that n1. I will give some shape here, like what is the shape I want? Previously it was 2, 3. Now I have to make it as 3, 2. I'll make it as 3, 2. Even you can use 6, 6, that is one dimensional. Okay, so now if I run this code, see guys, I got it as 1, 2, 3, 4.
let me print this. I'll print n1 dot shape. I will print n1. Let's run this. You can see previously it was 2 by 3. After reshaping it becomes 3 by 2. Nihal is asking what is the difference between np dot shape and np dot dimension. Np dot shape is shape of the given array, number of rows and columns. Dimension is whether it is a 1 dimension, 2 dimension, 3 dimension, that is a shape. That is the dimension. Difference between two. Try this one, guys. Reshape. np dot reshape. Very important. Okay, I hope everyone is clear with this. So this is about reshaping. These four are very important thing. Right. So here we'll understand one more concept, like for suppose I will take one list here. I'll take one list, something like L1, list 1. I'll take one list, one dimension, 1, 2, 3, 4, 5. 5 elements are there. Okay, I want to create a numpy array for this. Okay, I'll say np like array a1, array 1. If I want to create numpy array, I should use a function np dot array. Okay, np dot array. And for this, I should give array like data. Okay, so array like data. What is the syntax of this? If you want to check the syntax of any given function, okay, you place the cursor on the function. Place the cursor on the function. Okay, and press, concentrate guys, place the cursor on the function and press shift and tab at a time. Shift tab. If I press shift and tab, it will show me the syntax of that function. Okay, this is one shortcut. Instead of going to the internet and checking, you can also check like this in the Jupyter notebook, not in other. If you are using Visual Studio, it automatically display while you are typing. Okay, if you are using Colab, you have to type and wait for 2 or 3 seconds, it will display. But in Jupyter notebook, we should use shift and tab, that is auto complete option. Okay, or else you can sorry, not auto complete, it will show the syntax. Okay, in this one we have one thing called as object. Object is normal. Okay, so array like data we have to give, it's an array like data. Object is an array like data, one array you have to give. Okay, so second one, D type. Very important. What is D type, guys? Okay, D type is very important. Okay, before understanding D type, let us understand what is the type of data here. I'll just created L1. If I print type of A1, or else if I want to create numpy array directly, I can view the array like this: 1, 2, 3, 4, 5. Okay, I can directly view the list data like this to this array. Okay, here you have to understand, if I print type A1, it is showing me that it's of a type numpy dot n dimensional array. Okay, this is actual type of this variable n1. Then what is this D type? What is this B type? Data type. What is this B type? Okay, D type is nothing but, you seeing these numbers inside a list? What is the data type of the list elements, guys? What is the data type of elements, numbers present in the list? Can anyone tell me? Zoya is saying it's a int. Very nice. Okay, it's an integer, right? If I want to check what is the D type of given numpy array, if I write print, okay, I will use A1 array1 dot, there is a function called D type. Let's run. So what it is saying, guys, just observe this one. What it is saying, A1 dot D type. If I use this attribute D type, it is returning me int 32. Means whatever the values you have inside this numpy array is of type integer. Okay. Even you can display this print A1. You can see if I print A1, you can see that inside this numpy array there are integer values 1, 2, 3, 4. Okay, but in the function even I can change that D type. If I say D type, if I want to make it as a float, I can use string data. I can make it as a float. Concentrate, guys, this is very important. Okay, so what I am doing here, I have used one more parameter D type, one more parameter D type. Okay, if you check the syntax of this function, you'll find one parameter called D type. If you use D type, and you specify the required data type, you may set it as a float, set it as a string, whatever you want. Okay, I set it as a float in a string format here. Okay, make sure that the type what you are mentioning, that should be in a string format. So this is a keyword for float. If I run this code, you can find the output is having the float data. You can see 1 dot, 2 dot. Even though I have given integers in a list, it doesn't matter. But all the data will be taken and it will be modified into D type. Okay, that is the importance of D type in NumPy array. D type means data type of elements present in an array. Yeah, please try this one, guys. Try with some other D type. I'll make this as a string, str. Observe, guys. If I make this as a str, if I run this code, I got this as a string data. So 1, 2, 3, 4, 5, it's a string. Similarly, you can make it as a float. It is by default taking float 64. If I run this code, it will take float 64. Float 64, 64 bit of data. If I say int here, int, instead of float, if I make it as int, let's run this. It becomes int 32. If I run this code, it will become int 32. Right? If I want to make the 32 is default here for integer. If I want to make 64 bit of integer, I can simply make int 64. Int 64. Let's run this. Now it becomes integer 64, guys. Okay, so that is the importance of D type in NumPy. Try this one. All of you, please try this. Okay, I hope everyone is clear with this D type. D type is used to modify the type of given array. Right. Similarly, we have different types of functions in NumPy. We'll discuss one by one. Okay. We understood how to create an array in NumPy. We understood how to create two-dimensional array. Similarly, you can try for three-dimensional array as well. Okay. So let us understand three-dimensional array. So I will give a small task. Let us try to create three-dimensional array, guys. Okay. So how we write two-dimensional array? How we write two-dimensional array? We write two-dimensional array like this. Okay. If it is 4 elements, 4 comma. Sorry, one-dimensional array. This is called one-dimensional array. Okay. So how we'll be having the elements in this one? This is very simple. Okay. So one-dimensional array, like one-dimensional array, the shape is 4 comma. We'll be having 4 values. 1, 2, 3, 4. Okay, this is called one-dimensional array. Right, 4 comma. Similarly, two-dimensional array, 4 comma 3. Okay, sorry, 2 comma 2, two-dimensional. Okay, how you create the array? This is also very simple. You should have 2 rows and 2 columns. Okay, 2 rows and 2 columns. Like inside this, one more bracket. So don't forget the commas here, guys. Commas. Okay, 2 cross 2, 1, 2, 1 comma 2. Then another list, because 2 here, 2 rows. In between a list comma 3 comma 4. This is two-dimensional list what we have defined previously. Two-dimensional list. What about 3-dimension, guys? 3-dimension. Okay, what about 3-dimension? 3-dimension, for suppose I'll give a dimension here. Number of channels 2, number of rows 3, number of columns 2. Try this one.
Anyone, please try this and share it in the chat box. Okay, have you done? Can you specify the question, Nihal? Sir, can't we give D type as immutable object like tuple? No, we cannot give. How can you give? D type is a primitive data type. It may be int, float. No. Okay. So just let me show you. First is number of channels. 2 channels, right? For 2 channels, we have 2 inside bracket. This is 1 channel inside bracket. Okay, this is outer bracket. Okay, for this. Okay, so outer bracket, inner bracket, 2 channels we have. 2 channels, 1 list. This is separated by comma. Inside each channel, there should be a 2 rows and 3 rows and 2 columns. Here we should have three rows and 2 columns. Okay, how can I write here? 3 rows means 3 lists inside. 1 list, another 1 list, another 1 list. Like this we should have. Okay. Overall, if you scan from the outer brackets, 1 bracket, another bracket, another bracket. This is 3 dimension. Okay. So this is 3 dimension, guys. Right. So this is 3 dimension. So I will take here some data 1, 2, and 2, 3, and so on. Like that, 3 dimension we can create. Okay. I'll take one 3-dimensional matrix. Okay, I'll call this as L3. 3-dimensional list will take. Outer bracket, inner bracket, this is number of channels. How many channels? 2 channels. I'll just define here what shape we need. Shape should be 2 channels, 3 rows, 2 columns. Okay, first these 2 channels is 2 inside list. This is 1 list for 1 channel. This is 1 list for another channel. Okay, if you have a confusion, I'll write in a next line. We can write like this also. Okay, here inside this 1 matrix, 1 dimension, 2 dimension, 3, 2, 3 rows and 3 columns. 3 rows, 3 inside list. Okay, here also same thing. 3 rows inside list. Are you getting, guys?
So how many rows? 3 rows. Okay, 3 list. How many columns? 2 columns. I'll call this as 1 comma 2, 2 columns. Here also 3 comma 4, 5 comma 6. Similarly, you can give anything here. 11 comma 12, 13 comma 14, 15 comma 16. Let's run this. Okay, let me create the 3-dimensional array. I'll call this as n3 is equal to np dot array. Okay, I'll use here L3 input. Okay, so I will print what is n3. I'll print what is n3 dot dimension. Ndim is a function, is an attribute, and print n3 dot print n3 dot shape. Let's run this code. Let's run this. See guys, I got 3-dimensional matrix, 2 channels, 3 rows and 2 columns, and you can see the dimension is 3 and shape is 2 comma 3 comma 2. If you want some clarity, I will write some text here. I'll call this as dimension. Dimension is this, and I call this as shape. Let's run this. You can see guys, dimension is 3, shape is 2 comma 3 comma 2. Please try this one. All of you, please try this. Okay, so this is about 3-dimensional array creation. Okay, so till now we have discussed something. We have discussed what are the things we discuss in NumPy. Let's have a small like we'll discuss in brief. Okay, we discuss about NumPy array types based on the dimension. Second, we understood creating array, and third, we understood some terms. Okay, some terminologies. One is called NDIM. NDIM is a dimension. How to check the dimension? Okay, we understood shape. Wherever we go, we use this dot shape function to check the shape of any given 1 dimension, 2 dimension, or any type of arrays. Okay, and also we understood dot D type. D type. D type is used to check the type of the given data, and also we can use D type to set the type of the data. Okay, and also we understood dot reshape function. Dot reshape function. Reshape is a function to modify shape of a given NumPy array. So these are the things we understood. Now we'll go for some important functions in NumPy. Important functions in NumPy with respect to matrices. Important functions. Okay, so let us check what are the important functions present in NumPy. Right. So first we'll see matrix function. So we understood how to check the dimension. It's a NDAM. We understood how to check the shape. It's a dot shape. How to reshape it? The simple function reshape. Now we'll move on to the some NumPy functions. Okay. So here we have one first function of NumPy. What we are going to discuss, that is called A range. Okay, A range. Okay, what is this A range? Let's have a look. For example, how we are creating the NumPy array as of now, guys. So we are creating NumPy array by giving some hard-coded values. Okay. For example, if I want to create an array, something like AR array, how we create it till here. Okay. If I want to create array, I will use a function called np.array. This is a function. I'll use this function as function to create an array. And for this function, we have to give the input, which is in the array-like format. Some hard-coded values you have to give 1, 2, 3, 4. This is hard-coded value. But I don't want to give hard-coded values, already known values. I don't want to give hard-coded values, but I want to create the value. But I want to create the values here. Okay, so using some logics. Okay, first logic, I want to create some range of values. Okay, for example, we know that in the range function we have seen range function will take some values like 0, 10 means it will give a series of range series of numbers. Okay, but if I want to create a range of numerical array, NumPy array. For example, NumPy array which consists of some values like 0, 1, 2, 3, so on. Okay, till something like 100. I cannot able to give hard-coded values, right? I cannot type 0, 1, 2, 3 till 100. I cannot type, but I can use some function which is helpful to create some range of values. Okay, so that function name is np.arange. Okay, in this one you have to give the input. Okay, we'll understand what is this arange function. Okay, so come to this PPT. Here we have three important arguments we need to pass, three important parameters. Okay, one is called start number. Second one is called end number plus 1. And the third one is called step. Okay, we'll understand step later. First, we'll go for start number and end number. See, guys, I want to create something like values in between 0 and 10. 0, 1, 2, 3 up to 10. Okay, so how can we create these values using arange function? I'll say n1 is equal to, what is the function? np.arange. np.arange. Okay, so here I should give the parameters like different arguments I need to pass. What is the first argument, guys? Here the first parameter what we need to pass is start number. Okay, start number. So here in the arange function we have to give start number, and second one is end number plus 1, and the third one is step. We just observe this syntax: start number, end number, and step. Okay, here I'll give start number. What is the start number here? 0. I'll give 0 here. What is the end number? That is 10. End number plus 1. 10 plus 1, 11. And what is the step? Here you can see 1 minus 0 is 1. 2 minus 1 is 1. 3 minus 2 is 1. Means which is 1 step. Okay, step equals 1. Okay, let me print this. I'll print n1. N1. If I run this code, see guys, I got the values 0 to 10. Similarly, if you want 0 to 20, 0 to 20. Okay, if you want 0 to 50, you'll get 0 to 50. Sorry, okay, 0 to 49, because 50 minus 1, 49, right? If we want 100 numbers, 0 to 101. If you want 10,000, you can get it 10,000 plus 1. You get those values. Okay, all these values present in this. Okay, so like this we can create like a range of numbers using a range, but make sure that all these a range function is one dimension, not multi-dimension, one dimension. Okay, so n1 dot ndim, it's a one dimensional, guys. Okay, so try this one. Siddharam is asking, show me the full screen of Jupyter. If I show full screen of the Jupyter, you cannot able to see. Is it visible, guys? Can I show like this? Is this okay? Okay, I'll maintain this much. Okay, so that it will be helpful for you. If you want to zoom it, you can zoom it in the screen itself. If you are using mobile, you can do it. But if you are using laptop, means it is tough. Okay, right. So I hope everyone done with this. So what is other function? We have linspace. Okay, linspace means the values are having linearly spaced data. The values are linearly spaced. Okay. Here we have to give start value, end value, number of items we want. Here we don't have step, but we have number of items. Okay. So no step, number of items. So let us understand this. I'll use linspace. So here I'll use a variable name li is equal to np dot linspace. Okay, what are the value range you want? I want the values from 0 to 10. Okay, and I want number of elements, that is 10. If I run this code, let us check what is present in this. I'll print li. So here we got linearly spaced element. Okay, 0 dot 1.11 between 0 and 10. It is linearly spaced. If I say 5, 1, 2.5, 5, 7.5, and 10. Okay, linearly spaced. Okay, if I say something like 6, linearly spaced data like this. Okay, so this is about linspace, guys. Okay, I hope this is clear for all. So we'll move on to the next one. Now we have one more important function. I'm audible, guys. Please reply. I got a problem. Not an issue. Yeah. So I think it's about to end the session. So till here we understood what is NumPy and all. The remaining sessions of the NumPy, the remaining concepts of the NumPy will be discussed in the next session tomorrow. Okay. Any questions? If you have any questions, please discuss. We can clarify the questions, guys. Any question? Yeah, Sumer is asking, can we pay 200 for the certificate now? No. Okay, we'll inform you. We have not created the link. Okay, we cannot allow anyone to pay now itself because we have some protocol, company's protocol. We cannot break it. So we'll tell you, okay, when you have to pay, like by end of the internship, maybe the last week, 4th week. Okay. Yeah, any question, guys? Till here, whatever we discussed, any questions? Okay, I think there are no more questions. Right. Uh, in the next class, we are going to discuss some more concepts of NumPy. And tomorrow's session, we also try to start Pandas library, which is very, very important. Okay, I request all of you, please attend the session without miss. And so we are going to discuss some more concepts of Pandas tomorrow, right, which will be helpful for our applications like AIML and so on. Okay, so I hope no questions. So we'll end up the session here. We'll see in the next class. Okay, so and I wish all of you guys, please go through the recorded session if you have not attended any previous sessions. Okay, and also whatever the documents we are going to share in the group, please go through it. Okay, and try the projects whatever we solved in the session, as well as whatever the problems we have in the PPTs. Okay, so please try that one, guys. See you in the next class tomorrow. We'll meet. Okay, till then, take care and clear, like go through all the concepts.